So first of all, thank you for being here. Although I have to kind of doubt your rationality because it is a nice day out, but thanks for being here. You know, the problem of giving a talk at a conference at the place you work is you got to run around and work and you miss most of the conference. But the little bit of it that I've caught, I mean, the talks have been really fascinating, really interesting. So my official topic is adopting no regrets policies and how they can save lives. I'm not exactly going to talk about no regrets policies, since I think we're the kind of animals that can regret anything. So there isn't much that's really no regret for us. So the first point I want to make, so a lot of slides are going to go very quickly, is finally health professionals are starting to get on to climate change, right? And this conference is an example of that. But we've got papers in the Annals of Internal Medicine, the New England Journal of Medicine. These are just sort of recent papers that are about the health impacts of climate change, and about trying to mobilize the community to, to begin to address this issue. There was a major report produced 2 years ago, Climate Change is Harming Our Health, by a consortium of medical societies that represent lots and lots of docs, lots and lots of societies. And people are beginning to sort of develop conceptual frameworks and sort of theories about how to think about the relationship between climate change and health issues. And so here's just one of them. I'm going to very quickly flip through a couple of them. And most of the talks today you could probably locate in one of those bubbles somewhere. Here's another one. You know, some people like flow charts, other people like circles. You know, there's sort of different ways of trying to represent these relationships. This is from a PNAS paper from 2013, which again makes you sort of see that these things are beginning to be thought about in high places, and that's good, that's important. And we've got some numbers. These numbers are not to be taken very seriously for all sorts of reasons that we can talk about if you want to ask in a Q&A. But basically what we know is that climate change is going to kill massive numbers of people, right? And trying to be a little more specific than that is probably not a good thing to do for all sorts of reasons. You probably heard some of those reasons earlier today. Now, one thing we do know that is really important, of course, is that the health effects of climate change are going to be another one of those health disparity issues, right? The people who are going to suffer and die disproportionately from climate change are people who are poor, are people who are disempowered, overwhelmingly in the global south rather than the global north. And we'll be talking about the challenges in trying to address climate change, but in a way, the simplest way of thinking about the challenge is really that it's the rich people who do most of the polluting, and it's the poor people who are going to suffer most of the effects. So the structure of, so it's even worse than this, but just as a first approximation, the structure of this issue is how to get the people who are doing most of the polluting and benefiting from that polluting to actually stop doing it when they're not the ones who disproportionately feel the effects. That's part of why this is such a hard issue to address. There's a whole lot of other reasons why it's a hard issue to address too. So anyway, welcome public health. Health has been, I think, historically a neglected dimension of this problem. And I think that health concerns can actually be powerfully motivating for individuals. I mean, people care about their health, and they'll act on the basis of health concerns in a way that's hard to get them to act on the basis of just environmental concerns or other kinds of concerns. And also, I don't know how much you guys really like to talk about this, but you know, the sort of public health world has a whole, who else? What other part of American society can actually get the government to lock people up without trial, also known as quarantine, right? I mean, there's a lot of power that goes with something being a public health emergency or a public health problem. We can actually do things as a society in public health contexts that we can't actually do in other domains. So So this world that you represent is potentially a very powerful world to bring into the climate change discussion. Okay, so, but I always, like some old dead person said that you should remember the past in order not to repeat it, but since I'm not very good at remembering the past, I can't remember who that was. But
George Santayana.
Thank you. Philosopher, in fact. Yeah, that was a trick. He's my plant. But so I think it's always important in talking about climate change for us to just be reminded that this isn't an issue that Al Gore invented when he decided to run for president, and it's not an issue which nobody has tried to address before a 29-year-old congresswoman from the Bronx decided to run on the Green New Deal, right? But this is an issue that's been around for a long, long, long time, and a lot of people have thought about this issue and tried to address it, and so far we don't have much to show for it, and we need to understand something of that history and why that's true. So Svante Arrhenius was a Nobel Prize winning chemist, Swedish, and in 1903 he did a series of calculations before computers. What else are you going to do in those long, cold, dark Swedish nights except do really tedious calculations? And basically Arrhenius computed that a doubling of atmospheric carbon dioxide would produce about a 1.5 or 4.5 degrees centigrade warming. Basically, he was right. That's pretty much the window of what a CO2 doubling does, okay? 1903. By the 1930s, a British engineer, Guy Callender, thought that he could already detect the signal of a global warming that was already underway. Roger Revelle, who's a very interesting figure, who was the founder of the University of California at San Diego, was an advisor to many presidents, was Al Gore's teacher at Harvard, a class in which Al got a C, but that can stay in the room. But he and Hans Seuss, who was another Nobel Prize winner, wrote a very important paper in 1957 in which they said human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past and be repeated in the future. Within a few centuries, we're returning to the atmosphere and oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years, right? Very clear-minded in 1957 about what we're doing. We're taking all this fossil carbon, we're putting it in the atmosphere. What a cool experiment. What's going to happen, right? Now, as I said, Revelle was an advisor to presidents, in particular Lyndon Johnson, and in 1965, in a message to Congress, President Johnson said, "This generation has altered the composition of the atmosphere on a global scale through radioactive materials and steady increase in carbon dioxide from the burning of fossil fuels." So already a presidential statement in 1965 about what we're doing to the atmosphere. Daniel Patrick Moynihan, a lad from Hell's Kitchen who became a United States Senator from New York and then actually worked as a White House advisor to President Nixon, wrote a memo in 1969. By the way, I should say that these, I got my laser here, that these numbers here are the parts per million of carbon dioxide in the atmosphere at the time people are making those statements. And so you'll see those numbers kind of eerily creeping up as we go through the history. So anyway, so Moynihan writes to John Ehrlichman, who was Nixon kind of had a right-hand man and a left-hand man. And Ehrlichman was kind of Haldeman and Ehrlichman, right? And so Ehrlichman was one of those. And he writes to him in a memo, "It's now pretty clearly agreed that the CO2 content will rise by 25% by 2000. This could increase the average temperature near the Earth's surface by 7 degrees Fahrenheit. This in turn could raise the level of the sea by 10 feet. Goodbye, New York. Goodbye, Washington, for that matter." And then, like a good New Yorker, he adds, "We have no data on Seattle." So anyway, so again, this is the Nixon White House. And actually, Moynihan was a little bit pessimistic, which is good. Things have not turned out so far to be quite as bad as that. The New York Times in this 1977 and 1979 have headlines. These are headlines. This is the front page of the New York Times, and about what happens with the heavy burning of coal. In 1979, the National Academy of Sciences produces a report in which they say a wait-and-see policy may mean waiting until it's too late. Maybe somebody thought that they were recommending that policy. I don't know, because that's pretty much what we've done. In 1988, Jim Hansen, a climate scientist at Columbia, gave congressional testimony that was, again, on the front page of the New York Times, in which he says, global warming has begun. Okay. So these are not state secrets, right? I mean, this stuff has been out there for a long time. Senator Tim Wirth of Colorado, in the same year, introduced a bipartisan bill with 15 co-sponsors calling for a 20% reduction in greenhouse gas emissions between 1990 and 2000. Again, we'd be in a completely different world if this bill had been enacted and actually implemented. And in 1988, the international process for negotiations about climate change was launched on the basis of a resolution from the UN General Assembly. And some of you here may be old enough to remember the Rio Earth Summit, which was the largest gathering of heads of state ever brought together. That's where a number of environmental treaties were signed, including the Framework Convention on Climate Change, of which the ultimate objective is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. Essentially, every country signed this treaty, every country ratified this treaty, and every country is now basically in breach of this treaty. Okay, that's the sad truth about climate change. Now, one of the things Roger Revelle did for us is he managed to get funded and put in place an observatory in Hawaii that measures atmospheric carbon dioxide going back to 1959. And what you'll see is we have this very steep upward slope. And guess what? Our emissions in the atmosphere don't actually care about things like newspaper articles and National Academy reports and UN treaties being signed and so on. All that stuff is going on down here on planet Earth, right? But in the atmosphere, we basically have an unbroken trend line of the buildup of greenhouse gases. Now, this is Jim Hansen recently, right? Jim Hansen has gone from being a nice, respectable climate scientist from Iowa who worked for NASA, doing what he's supposed to be doing, giving congressional testimony, right, bringing his science to decision makers, to becoming an activist who now gets regularly arrested performing acts of civil disobedience. That, I think, is a pretty good metaphor for how a lot of us who've been working on this issue for so long actually feel about the trajectory and the failure of society and our political system to really have uptake on the science. Okay, now here's the thing. The longer that we delay action on a problem like climate change, the more complex the problem becomes, the more expensive it is to address, and increasingly we move from prevention, and you guys all know better, prevention's better than a cure, whatever that slogan is, medical people like that. We kind of move from prevention to mitigation. Let's try to make it not as bad as it would otherwise be, to adaptation. Well, it's happening, it's bad, let's learn to live with it, to what you might call remediation, which is this whole area that people are starting to think about. Well, what if we inject a bunch of sulfate particles into the stratosphere and actually reflect some solar radiation back into space and kind of cool things down? Now, that's really the kind of thing serious people are talking about, and that might kind of fall in that category of the cure being worse than the disease, right? But it's something you're going to be hearing a lot more about in the future. Okay, so what I want to say is that people talk about the problem of climate change, the problem of climate change. It's not really a problem anymore because it doesn't really have a solution. Problems have solutions. Climate change is really more of a syndrome that we're going to have to figure out how to manage and muddle through than it is a problem. And so we're now in this area of a mix of mitigation and adaptation, as I was saying, more pressure for remediating the climate. And people kind of said, oh, there's no, first it was like a silver bullet. No, there's no silver bullet. It's like golden buckshot. It's not even golden buckshot anymore. It's just essentially throwing mud at the wall across a whole range of possible responses. Okay, but there are a bunch of things that we can do in each of these categories. And I'm going to talk about some of them, not in very great detail, but I will talk about some of them. But the first thing we need to do, which I think people don't pay enough attention to, is to recognize that there isn't really a single, even if we think of emitting greenhouse gases as a problem, there isn't a single problem of greenhouse gas emissions. So there's a whole basket of gases that actually have warming effects on the atmosphere. And those gases actually have quite different properties. So one difference among them has to do with what's called their residency time in the atmosphere, how long they hang out in the atmosphere, warming the atmosphere. Although it's not on this chart, basically carbon dioxide can hang around in the atmosphere between 25 years and about 500 years. Some gases that are man-made by humans, none of them on this chart, but some of the other chlorofluorocarbons actually can hang around for centuries and centuries and centuries, even more than carbon dioxide. Methane, CH4, is relatively short-lived. It only hangs around for about 12 years in the atmosphere, but it does much more warming than carbon dioxide does. So there's this concept of global warming potential where carbon dioxide is defined as 1, and then other gases are defined in relation to carbon dioxide. So methane is 72 times more powerful as a greenhouse gas than carbon dioxide. And then NOx and the CFCs are even vastly more powerful than that. So we really have a bunch of, so each of these gases or families of gases actually represents a somewhat different problem because they have different sources, they have different properties, and they have to be mitigated or controlled in different ways. So if we focus on carbon dioxide, which is the one that everybody talks about, people tend to talk about this as a carbon problem. Well, we know a big part of the problem comes from generating electricity in coal-fired plants. And we also know it comes from transport, from driving around in cars and flying around in airplanes. And it also comes from the way we heat and cool our houses. And by the way, I couldn't help but notice in the previous panel, it was sort of said, again, without much irony, because we're sort of in a kind of this kind of world that, as a result of climate change, it's going to be hotter, and that creates all these health problems, so we have to stay indoors and turn up our air conditioners. What does that do? It's a positive feedback on warming the world, right? But that's the kind of situation that we increasingly find ourselves in. So what's the solution to this, or how do we manage that? Well, even though we learned yesterday at a presidential press conference that wind turbines cause cancer, nevertheless, this is a risk that I would humbly suggest is worth taking despite the best science being articulated on the other side of it. So we know that, decarbonizing the energy system is where we have to move to deal with the carbon side of the problem. We can talk about how to do that and the policy issues involved and so on. But that's the approach to carbon management. And of course, the benefits, I'm not going to go into these because I think other people have talked about them, but they involve reductions in air pollution and all coal mines are not nice places to work in. They don't do nice things to mountaintops, right? So you sort of get all of those kinds of benefits when you move away from the fossil fuel energy system. Now, the methane issue is a different issue. It has different sources. So this is essentially a pie chart that's telling you about the sources of methane emissions. And the one I want to focus on here, although we could focus on others, a big source comes from the use of natural gas, but in particular leaks from natural gas pipelines and in systems of fracking. But the one I want to focus on is animal agriculture. which basically produces about 40% of those really nasty methane emissions, like 72 times more powerful molecule by molecule than carbon dioxide. Well, what can we do about that? Well, we can move away from having that for dinner towards having this for dinner. Now, that looks pretty radical, right? But that doesn't look so radical. Some of you may know that Burger King has just produced an Impossible Burger, which is essentially a plant-based burger. And we are going to be moving more into that world of plant-based substitutes as an approachable way of trying to reduce the methane footprint that comes from animal agriculture. And and there's a lot of health benefits from moving towards a less meat-heavy diet, obesity, diabetes, air and water pollution, and all those kinds of things, in addition to sort of animal welfare issues. Now, chlorofluorocarbons are an interesting case. Now, we think of chlorofluorocarbons as what destroyed the ozone layer, and that's true. And the Montreal Protocol and that attendant regime has been a great thing in terms of the recovery of the ozone layer. In fact, part of what misled us on the climate problem is we did so darn good with ozone and chlorofluorocarbons, we thought actually tackling climate change would sort of be like the same thing. And in fact, there's all sorts of interesting reasons why they're not. But an interesting thing here, so this is essentially a chart that shows you the regime. Everyone knows the Montreal Protocol, but it's been amended. But what's interesting is probably the single most effective thing that the nations of the world have done to actually keep the warming down has been by controlling chlorofluorocarbons. And the latest amendment to the Montreal Protocol is this thing called the Kigali Amendment, which brings under control a particular kind of human-made CFC. And essentially what this chart is showing you, and so weirdly, the current administration did not object to the Kigali Amendment. Probably they were too busy trying to figure out how to build a wall or something to really notice it. But essentially, what the Kigali Amendment does is it holds the warming from these HFCs to about, the additional warming to about 0.06 of a degree centigrade. And without that amendment, projecting out over the next century, it would have produced another 0.5 degree centigrade warming. So that's a huge effect. So the point I'm trying to make here is, we think, we want to do something about climate change, but, oh my gosh. So, but most of the things we can actually do are these kind of add-on type things, these things that have additional ancillary benefits that we might not think of as being primary. So I'm going to skip a bunch of stuff now because that's all in the mitigation side. Now we can talk about adaptation. That's New York underwater. Those are some of the plans people are talking about to protect New York. We also have this idea of managed retreat, just get the heck out of there, right? Let the sea reclaim the place. Not everybody likes this idea. But the more fundamental challenge here is resilience in the face of change. Is that what we know is that the environment is changing, and it's changing rapidly, it's changing dramatically, it's changing because of human action, and it's changing in ways that are unpredictable. And so what we need to think about really beyond mitigation, beyond adaptation, is to think in terms of resilience. What do we need as a society to allow us to kind of surf the waves of that kind of change that's happening so rapidly? And one of my major takeaways, again, don't have time to really talk about, is that resilience isn't just a science and technology issue. It's really about a political and social issue. It's about the ability of our political systems to actually make policy and create regulations in response to changing conditions. It's about having systems of public health that are in place that allow us to respond to health emergencies, right? All that kind of social structure is part of what resilience is really about. Okay, these are some of the obvious challenges that we face in addressing climate change. Again, I'm going to skip over them very quickly so we can get to the end. There's some interesting, I mean, I think part of why health has not been so much part of the conversation actually has to do with the way our funding mechanisms and funding sources work, which is another interesting thing to think about. But success can be possible. Now, I'm going to spend a couple minutes on this. I mean, the CFC case is one successful case, but we're on the verge of another big success here in New York, congestion pricing, which just passed the legislature. And it does have some really important lessons for us who kind of want to address these issues, I think. So you got buy-in from right-wing organizations like the Manhattan Institute that recognizes that reducing travel time is important for the economic health of the region. You got buy-in from anti-poverty organizations who did calculations that, let's face it, the people who are driving around in cars who are going to pay these charges are not the poorest people among us. And so congestion pricing is going to benefit poor people through less air pollution, better subways, all sorts of things like that. Now, this is a kind of benefit cost analysis that you shouldn't take too seriously of congestion pricing. But what I think is, because I don't really believe it, again, we're back to numbers, you can't really believe them, just believe their directionality. But what's interesting about this is what drives the positive benefit cost analysis is essentially saved driver time. Environmental impacts, wellness impacts are relatively minor in the benefit cost analysis. But for us, they're the big ones, right? And so part of why congestion pricing has worked politically is because we have been able to get this by tacking it on to this. And that's going to be the structure of a lot of what looks like success on these issues. Now, having said that, I have to tell you something kind of depressing, which is a survey came out the day after the vote was done in the legislature, and the majority of New Yorkers in every borough oppose congestion pricing. Even in Manhattan, where most of the benefits will be, they oppose congestion pricing. The ethnic group that opposes it the most are African Americans, even though if you did a kind of ethnic analysis of the benefits would disproportionately accrue to African American communities in the city. That's how hard it is to make progress on these issues. Okay, I think air pollution is kind of a potentially very powerful wedge for a lot of these issues. We don't really know what direction this is all going to go in, how bad it's going to be bad. We don't know how bad it's going to be. We don't know how successful we're going to be at managing these problems. I wrote a book called Reason in a Dark Time, why the struggle against climate change failed, what it means for our future, where I try to talk about some of these issues. George Bush Sr. once famously said the American way of life is not up for negotiation, but it is. The world, reality, the earth, is putting it up for negotiation. There is change underway. It's going to happen. The only question is how we're going to manage it, if we're going to manage it at all. A change is going to come. And so I'm going to leave you with the words of the person who got me involved in climate change back in the late 1970s at the National Center for Atmospheric Research, Mickey Glantz, who said, well, you got to live like an optimist, but think like a pessimist. Thank you very much.